Alright, what's up everybody? I'm back today with another video, and in today's video we're going to focus on equivalent resistance, specifically with Y delta transformations, right? So that's what we're gonna focus on. So here we have a resistive circuit, and we have to find their equivalent resistance. So REQ means equivalent resistance between X and Y if A is equal to 3, right? So we have to find the actual value of the resistors first with A equal to 3. And then we're going to find the equivalent resistance between X and Y, right? So we're going to take a look at this problem. So the first thing let's do is figure out what the actual values of these resistance are, right? So if we have 3 plus 2, we know it's actually 5 kilo ohms on the top, right? We get 5 kilo ohms at the bottom. And then we have 3 plus 1 and 3 plus 1 because A is equal to 3. So we have 4 kilo ohms respectively on the top and bottom on the right side, right? So we have 5, 5, 2. And then we have 4, 4, 2 over here, right? So what can we do to find the equivalent resistance between X and Y? Well, we need to do something called Y delta transformation, right? So essentially what that is we have a triangle of resistors, right? So we have a resistor over here, we have a resistor over here, and we have a resistor over here, right? So let's label this R1, R2, and R3, right? So we have 3 resistors over here, and essentially what we do when we have a triangle of resistors is we take this R3 value, right? We take this R3 value and we kind of move it and attach it over here to this node. So essentially what we get is we have a resistor coming down like this, and then we have 2 resistors over here. So we have R3 over here, and then R1 and R2 stay in the same position, right? So then the R3 kind of moves, and we rotate it 90 degrees and we put it on this node over here, right? So now we have a new format of 3 resistors, R3, R1, and R2, right? So now that we know that, what can we do to find the values of these resistors, right? Well, we know how to do parallel and series. So to find the value of what R3 is equal to, R3 is equal to R1 multiplied by R2. So these are the rules for this, right? So when the resistor that's vertical on its own, vertically over here, right? R3 is equal to R1 times R2 divided by R1 plus R2 plus R3, right? So we have R3 is equal to R1 R times R2 divided by R1 plus R2 plus R3. So that's the rule for R3. Well, what about R1 and R2? Well, what's the rule for R1? R1 is equal to, so we're going to take R1 and multiply by R3, R1, R3, and then the same thing, R1 plus R2 plus R3, right? So we have R1 times R3 divided by R1 plus R2 plus R3. And the last resistor R2, well, R2 is equal to R2 times R3, right? In the same position, right? So if R3 is on the top and R2 is over here, R2 times R3, this is what R2 is equal to after the equivalency. So R2 times R3 divided by R1 plus R2 plus R3, right? So guys, these are the rules for Y delta transformations. You can either memorize it, write it down, but these are the equations for the 3 resistors that it's constant all the time, like nothing really changes it. So we have R1, R2, and R3 set up in a position like this in a triangle, and we want to find the equivalent resistance of this. So we take R3 and we move it to this top node over here, and then we essentially get this formation. And then these 3 equations for R3, R1, and R2 are what we essentially are going to use to solve the equivalency, right? So this is just a quick example of what Y delta is, but I think you'll better understand it in the example. So let's apply it to the circuit we have above, right? So let's go ahead and do that. So if we look at the circuit above, right, we're trying to essentially see if there's a triangle form over here, right? Well, if we look at this X node, it might be kind of hard to tell, but let's kind of look at this left side over here, right? So if we look at this left side over here, the 2K, the 5K, and the 5K, right, at this X node, right? So essentially, if we write this X node horizontally, right, like this, and instead of drawing it straight, like this line over here, if we cut it down like this, it essentially looks like the triangle that we're trying to get over here, right? So if we go ahead and do that, if we go diagonally, and we have a resistor over here, we get 5K. And if we go diagonally over here, we only have a resistor over here, we get 5K. And then if we go horizontally, or vertically, I mean, right down, we have the 2K over here. So if we cut this circuit in half real quick, we see that if we then rotate this triangle, we essentially get X on the top, we get 5 over here, 5 over here, and horizontally we get a 2K, right? So we have 5K, and 2K, right? So this essentially looks exactly the same as the diagram that is shown over here, that's drawn over there, I'm sorry, to solve for the equivalent resistance of that Y delta transformation, right? So let's go ahead and do that and simplify it, right? So that's what we're going to do. We kind of split up this circuit in two, right? So we have a Y delta transformation over here. So we have 5K, 5K, 2K, and you can see how we got that. So they kind of see, and they probably try to trick you by making it rectangular, right? But we can just see that if they're connected to the same node, we can draw this line in any form. We can draw this line like this, like squiggly, squiggling down, go straight, ziggity dag. Like all of it is the same, right? So we can just make it a triangle as long as it's just connected to the same node, which is node X over here, right? So knowing that, let's go ahead and solve for what that's supposed to be, right? So we know our equation, right? So what are we going to do to transform this? Well, we're going to take this 2 and bring it to the top, right? So R3 comes to the top. So we know that we're going to have an X node over here. Our R3 is going to be here, which is 2K, right? Then we have on our both sides, we have our 5K, right? To get the Y delta transformation circuit like we found before, right? So essentially this is what we get. And we have to solve the equivalency for each resistor. The equivalency of the 2K resistor, the equivalency of the 5K resistor, and the equivalency of the 5K resistor again. So let's go ahead and do that. So what about the 2K resistor? Let's label this R3, R1, and R2, right? So for R1, or let's start with R3 actually. R3 is equal to, we know that 5 times 5, right? So we have 5 times 5 divided by 5 plus 2, right? Because that's our equation. We get R1 times R2 on the top. So 5 times 5 divided by R1 plus R2 plus R3. So essentially we get 5 plus 5 plus 2 on the bottom. And what is this equal to? Well, R3 is then equal to, we have 25 at the top divided by 5 plus 5 plus 2, which is equal to 12, right? So we have 25 divided by 12, right? So let's go ahead and put that in decimal form, which essentially is equal to 2.08 kiloohms, right? So we know that this top 2K essentially becomes 2.08 kiloohms, right? So if we're going to write down our new diagram, we know that if our X nodes over here, and we have our resistor coming vertically, this is now becoming 2.08 kiloohms, right? So what we have to do is find out what the 5K and the 5K essentially become as well. So let's go ahead and do that. So what about for R1? We know our equation for R1 is equal to R1 times R3, right? So we have 5 times 2 divided by 12 on the bottom again, because it's R1 plus R2 plus R3. So we put 5 plus 5 plus 2, which is essentially 5 times 2 is equal to 10 divided by 12. And in decimal form, what is that equal to? It's equal to 0.83 kiloohms, right? So we know that R1, if we go horizontally this way, this is equal to 0.83 kiloohms. That's what it becomes, right? Now, another fact we can do is that for since we know that R1 and R2 are the same values, R2 is essentially equal to what R1 is, because it's the same thing, right? So if we go ahead and just do it mathematically, R2 is equal to 5 times 2, right? So R2 times R3. So we see 5 times 2 for R2 times R3. So we get 5 times 2. And the same thing, 5 plus 5 plus 2, because we're adding up all the resistors. And we get 10 over 12 again, which is essentially 0.83 kiloohms, right? So essentially what do we get as our final? We know that R1 becomes 0.83 kiloohms. We know that R2 becomes 0.83 kiloohms. And then our R3 becomes 2.08 kiloohms, right? So essentially, our final circuit, if I'm going to redraw what's on the left here, our final circuit, we have our X node. On the bottom, we get 2.08 kiloohms. And it splits over here. And it splits over here. And these are essentially each 0.83 kiloohms, right? And that is essentially what we get, right? But we're not done the problem, as we only solved the one part of the circuit, right? So we have this part of the circuit over here, but now we have to attach it to the top part of this, the right side of the circuit as well. So let's go ahead and do that. So now when we redraw this circuit with the changes we made, we can do X, right? And this goes, and we know that this top node over here, right? If we transfer what we just did, we know that if we rotate it 90 degrees, we know that this is 2.08, right? Then it branches out on each side, and we get 0.83 over here, and then we get 0.83 over here, right? So now we essentially kind of get rid of this middle road over here. So this goes away, right? So now we have this, and now it automatically connects, right? As there's no blockage in the middle, so it connects to what a plus 1 is equal to. So it's 4 kiloohms, right? So we get 4 kiloohms over here, and we get 4 kiloohms over here, essentially. And then now this then connects to 2 kiloohms, right? So when it connects, we know that it connects to the same node, right? So we know the 4 kiloohm connects like this, and then there's 2 kiloohms over here, right? And then we have our Y node right this, right? So we get 2.08, 0.83 branching upwards, 0.83 branching downwards. Then we get 4 kiloohms for this section right over here, right? So the a plus 1 and the a plus 1. And then there's a blockage of a node over here, right? So the 2K is not in series with it. But so the 4 kiloohms are connected to one another, and the 2K is then extended, right, with the Y. So eventually, this is what a circuit becomes, right? So if our circuit becomes this, let's simplify it even further and make it easier to solve, right? So essentially, we know how to find resistors in parallel, right? As we can see here, the 0.83 is in parallel with the 4 on the top, and the 0.83 is in parallel with the 4 on the bottom, right? As there's no node in between them over here, right? So these two nodes are non-existent. So these are in series. So essentially what this becomes is X, a node over here. Then we have a resistor, 2.08, and then we get a line up. And then what is 0.83 plus 4? Well, it's 4.83, right? So then we get one node, or one resistor, I mean, over here, 4.83 on the top. And we get the same thing on the bottom, 4.83, because it's 4 plus 0.83. And then we connect it like this. And then over here we have a node, and it connects to 2K, which is the Y. So now we have this circuit, which looks very, very simple to solve, right? It makes something so basic, so hard looking, so basic, right? So what can we do here? Well, we know that this 4.83 and this 4.83 are in series with one another, right? So now, because they're in series with one another, we can easily solve for that. So to find resistors in series, we know that it's just R1, R2 plus R1 plus R2, right? So it's R1 times R2 divided by R1 plus R2. So essentially, it's 4.83 times 4.83 divided by 4.83 plus 4.83, which is equal to 2.415, right? So we get 2.415, and then essentially our circuit then becomes, right? We got our X over here. We get 2.08. Then we get a straight line, and this then becomes 2.415, right? Then we get another straight line, and we have our 2K to end it off, and then our Y, right? So essentially, between X and Y, we have all these series resistors, right? So all this is in series of this one straight line with no nodes in between them. So essentially, the resistance between X and Y easily becomes 2.08 plus 2.415 plus 2K, right? So this is all in kiloohms. And then essentially our final answer of the equivalent resistance is the sum of these three resistors. And the sum of these three resistors becomes 6.5 kiloohms, right? So 6.5 kiloohms is the R equivalent, right? So the equivalent resistance of this whole circuit over here, right, of this top circuit, is 6.5 kiloohms. And you can see we had to do using Y delta transformations for the left side. So we crossed off the left side on its own. We did Y delta. Then we had to add these two series on the top, these two resistors in series on the top. And then essentially you had to finally put them in parallel, right? So we did find the parallel resistance between these two 4.83 resistors. And then we easily found these three resistors in series, and we added them together. And we got 6.5 kiloohms as the equivalent resistance between X and Y. And then that is how you solve this problem with a Y delta transformation to find the equivalent resistance. So if you guys understood in this video and you guys enjoyed, please make sure to like, comment, share, and subscribe. I would really appreciate it. If you guys have any comments or concerns, please comment down below or email me at sharranacademy@gmail.com. And if you guys want me to do any more questions like this or cover any specific topics or questions that you have, please comment down below and let me know, and I'll make sure to make a video on it as soon as possible. Alright, thanks for watching, guys.